Hi, my name is Gabrielle Bagdanis, and I am going to be doing a video about Lecture 3, which is about testing equivalence, validity, implication, and consistency. So before we get into all of that, I would like to remind everyone what connectives are, basically, and how they can turn into symbols, or can be demonstrated in symbol form, how to create truth tables, and how these connectives influence truth tables, and how to read truth tables. And then I will go over an example and clarify how to test equivalence, validity, implication, and consistency. So for now, arguments and symbols. So truth table logic involves two things: atomic sentences, which are also referred to as simple sentences, and truth functional connectives. There are truth functional connectives that can add on to an atomic sentence. These connectives are negation, conjunction, disjunction, conditional, and biconditional. I'm going to explain all of these in the next few slides. First, we have negation. The symbols for negation are these. I do not know what they're called, but it's basically this, or that. And we know that a sentence or atomic sentence is demonstrating negation if it is not the case that. So I could say a statement saying, I like candy. So that is a true statement. So I like candy is going to be our P. So that's true. It is not the case that I like candy, turning the P statement false. So we can see negation P, turning it into false. So if I say I like candy, which is a false statement, or I do not like candy, which is a false statement, we can turn it is not the case that I do not like candy, which turns it true. Conjunction is our next connective. It is represented by the symbols right here. And an example of this in an atomic sentence, or between the atomic sentences, are both or and. And the truth table for conjunction, we can see, is for P, I did true, true, false, false. For Q, I did true, false, true, false. So basically, to make the conjunction true, both P and Q have to be true. So we see in row 1, P is true, Q is true, meaning the conjunction of P and Q is also true. For P and Q in row 2, we see true and then false, meaning it is false. Row 3, false, true, meaning it is, again, false. And then false, false for row 4, meaning it is false. So the only time a conjunction can be true is if both P and Q are true. The next connective is disjunction. So the symbol is represented by a V, something that looks like a V. And that is shown in an atomic sentence or between them with either or. A truth table for disjunction is represented by, so first I once again do P and Q. So P is true, true, false, false. For Q, we have true, false, true, false. So PVQ, disjunction of PVQ, or the disjunction of P and Q. So we see that we only need one truth value in either P or Q for PVQ to be true. So to make it easier, I'll just go row by row. First row, we see true with P, and we see Q is also true, meaning that P disjunction Q is also true. So for the second row, we have P is true, and then Q is false, but we still have one true, meaning that the disjunction is also true. For row 3, we see P is false, and Q is true. We still have one true. That means that PVQ is true. But then, for the last row, there are no truth values that have true for P and Q, which causes the disjunction to be false. For a conditional, the symbol represented by a conditional is an arrow, a singular arrow, and that is important to remember. Conditional is an example of an if-then statement, and the truth table for a conditional is very interesting, and it was easy for me to remember, but I can see how many people can slip up on this. So basically, so every statement is going to be, every row is going to be true unless there is a situation where P is true and Q is false. That would make a false conditional. So we can go row by row. So in row 1, P is true, Q is true, so the conditional is true. Second row is where we run into this dilemma that I had mentioned. So P is true, Q is false, so this is the only situation where it's going to be false in a conditional. So the false is represented with this certain situation. So P is true, Q is false, that means the conditional is false. Then for row 3, we have P is false, Q is true. So that means P, the arrow, Q is true. And then for the last row, we have P is false, Q is false, so then the conditional is true. Now we go on to biconditional. So it is important to remember biconditional is the 2 arrows, not singular arrow, it's 2 arrows. So this is represented with the sentence, or like the little section that says if and only if. So the truth table for a biconditional is very easy to remember. Basically, both P and Q truth values have to be the same for the biconditional to be true. So, row by row, P is true, Q is true, they're the same, meaning it's true, the biconditional true. We have row 2, P is true, Q is false, they're different, that means the truth value for the biconditional is false. Row 3, we run into the same thing, where P is false, Q is true, they're different, meaning that the truth value for the biconditional is false. But then for the last row, we see false, false. These are the same, so the truth value for the biconditional is true. Now I'll give my example argument, and I think it'll be a little easier once we have an argument, and then we can create it into symbols, and then create a truth table, and then explain how we can test for equivalence, implications, consistency, and validity after we have the truth tables and can see all the truth values. So in this example, I created an argument that has S1 is, or premise 1, S1 is if I like fluffy animals, then I like dogs. For S2, premise 2, I said I like fluffy animals. And then for the conclusion, I said, thus I like dogs. So we can say I like fluffy animals can be represented by P, and then I like dogs can be represented by Q. We also see that it's an if-then statement for S1. If we remember, I'll scroll up. An if-then statement is represented by an arrow. So we will if-then, so that's going to be an arrow somewhere in this statement. So if P, then the conditional Q. The second sentence, the premise 2 is I like fluffy animals. So once again, we see P, we can put it here. And then thus I like dogs is the conclusion. So that is Q, so Q. So in symbol form, it's P, conditional Q for S1. S2, we have P. And then conclusion, we have Q. So now that we have that, we can construct a truth table. So I have written here what the symbol form of the argument was from the previous slide. And we're going to write the truth tables. So to make it easier for me, I usually write P and Q out first, just so I can have all my truth values. So usually there's a line here, but I don't know how to do that on a Mac, so I'm just going to leave it and pretend there's a line here to separate this S1, S2, and conclusion. So for P and Q, P I have TTFF, for Q I have TF, TF. So then we can write what S1 is. S1 is a conditional, so that's going to be the arrow, so P, the arrow, and then Q. So that's for S1. And then for S2, we write down P, and then for the conclusion, we write down Q. So once we have that, we can fill out all of the truth values. Usually I just do the simple task of filling the truth values of P and Q first, because then it makes it easier for me to understand what I need to do at the end. So for P, I look here. Okay, we have true, true, false, false. Okay, so I write down true, true, false, false. For Q, true, false, true, false. True, false, true, false. And then I do the same. P is true, true, false, false. And then Q, true, false, true, false. Yep, did the same. So now, if we remember, we have to remember how to, what like the P and Q have to do to, or like what basically the conditional truth value looks like. So we're going to scroll back up. So we see that P conditional Q, it is only false when P is true and Q is false. So let's go back to our example. So it will only be false, the conditional will only be false when P is true and Q is false. So first statement, or the first row, we have true and true, meaning it's true. In row 2, we have true and false, which is the situation I just described where it will be false. So the conditional is false. Then we have false and true, which is true, and then false and false, which is also true. So now, basically, we look at this truth table right here, and what can we do with it? There's a few things we can test after we have these values, these important values. So these are the important values of S1, here, 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 and here. The important values of S2 are right here, and then the conclusion's right here. So what does this all mean? Now we can test for equivalence, implications, consistency, and validity. What do these mean? I will describe right now. So the equivalence is defined as the sentence S1 and S2 are equivalent if and only if they always have the same truth values in the same cases, which is also known as rows. So we have to check the truth tables of the main connective in both sentences to see if they are the same truth values. So they always have to be the same truth values. So let's look back at our truth table. So we will be testing S1 and S2 because it is sentence S1 and S2 are equivalent if and only if they always have the same truth values in the same rows. So here I just highlighted it a little better for everyone to see a little clearer. So S1 and S2 have to have the same information, same truth values for it to be equivalent. So in row 1 we see true, true, meaning that's good, equivalent. But then we come into the issue and we run into the issue where row 2, row 3, and row 4 are not equivalent to each other because we have false, true, true, false, and then true, false. Meaning that S1 and S2 are not equivalent to each other because they all have to be the same truth values in the rows. The next thing we can test is implications. So with implications, sentence S1 implies sentence S2 if and only if whenever S1 is true, S2 is true. There should not be a case where S1 is true and S2 is false on the truth table. So let's look back at the truth table. So once again, S1 has to be true and S2 have to be true for it to work, for it to imply. So let's look for implication. So S1 has to be true, and if it is true, then S2 also has to be true. So here we have true, true. Good. S1 does imply for S2 in this situation. Looking here, F and then T. That's okay. But then we run into the issue where T and F. So once again, implication, S1 has to be true and S2 has to be true. There's not going to be a situation where it does not. So this means that it does not imply, S1 does not imply S2 in row 3, but also in row 4. The next thing we can test is consistency. This is when sentences S1 and S2 are logically consistent if and only if there is at least one case or one row where both sentences are true. So there only has to be one row that has to have true, true, which in my opinion, consistency is one of the easiest things to spot and find in a truth table. Now let's look back. As we already know, because we've been going over this truth table, the first row has true and true. So that means that it is consistent. Last but not least, we have validity. So validity can be stated positively using implication, which is a set of premises or sentences. S1 sentences logically imply a sentence C if and only if there is no row in the truth table where S1 sentence is true and then C is false. There should not be a true, true, false in the truth table. So let's look at our diagram. Let's look at our truth table. So there cannot be a situation where it's true, true, false. So let's look. So row 1, true, true, true. Okay, so conclusion true. Then we have false, true, false. True, false, true. True, false, false. So this means that we can conclude that the argument is valid because we do not have a situation where it appears to be that we have true, true, false. Therefore, this argument is valid. So now I have another example. So my example is, if I like the outdoors, then I like skiing. My S2, I do not like the outdoors, meaning the conclusion is I do not like skiing. So S1, if I do not like outdoors, so that's P, then I do not like skiing, Q, and then it's an if-then statement, so we have another conditional. Then I say I do not like outdoors, which is negation, because I do not like the outdoors, but above I said I like the outdoors. So negation P. I do not like skiing. Once again, we see negation, but with Q. So a truth table for this. So the symbols had been S1, P, conditional Q, S2, negation P, and conclusion is negation Q. So let's look at the truth table. So I wrote P is true, true, false, false. Q is true, false, true, false. Remember, think about there being a line here. And then I wrote P negation Q. And then, P conditional Q, negation P, and then negation Q is the conclusion. So once again, I just filled in what P stands for, TTFF, P here, TTFF, and then Q was TFTF, so Q, TFTF, and then Q, TFTF. And then negation P means the opposite of what we have for P. So we have true here, so false, true here, so false, false here, true, false here, true, and then same with Q. So we have false, true, false, true. I highlighted the important information. And then we do conditional, which, if you remember, is only false when P is true and Q is false. So that we only saw in row 2. So there's a false here. So we can test for equivalence. It has to have the same values in each row. So for S1 and S2, so true, false, we already see that we're running into a few issues, so it's not equivalent here. But for row 1, it is equivalent for row 2 and 3 and 4, but we see it's not equivalent for row 1. P is not equivalent with row, S1 is not equivalent with S2. Then we look at implications. S1 has to be true and S2 have to be true. So S1, S2, true, false. So we already see that row 1, S does not imply S2. Consistency is we have to have one row with true, true. So do we have a row with true, true? Yes, we have row 3, and row 4 with true, true, meaning that there is consistency in this argument. Last but not least, validity. We cannot have TTF, true, true, false, in our truth table. So let's look. True, false, false, that's okay. False, false, true, that's okay. And then row 3, we run into an issue. So we see true, true, false, meaning that this argument is not valid. And that is how we test for validity, consistency, implication, and equivalence. That's it. Thank you very much for listening.